Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, welcome to Happy Path Programming. Let's see, before we get into Trisha Gee, our wonderful guest for today, we've got Winter Tech Forum coming up in a couple weeks.
2 weeks exactly, almost.
Up here in Crested Butte, where we have lots of snow.
And you can still sign up, and you might be able to go to the yurt dinner. It's hard to say, but we've officially released the rest of the places. But
anyone that can make a last minute call,
it's a good time.
Here, it's going to be fun.
It's a really good time.
Yeah.
And also, just wanted to mention, I have a couple of books on LeanPub. There's Atomic Kotlin, and there's On Java 8, and there's, increasingly perhaps poorly chosen title, but people still get a lot out of it. So
the On Java 8 one.
On Java 8 one, yeah.
Nice. Cool.
Right, and then...
and Trisha, welcome.
And you have a book.
Yes. I see your Atomic Kotlin book on LeanPub a lot, because when I'm checking the top 10, yours is in the top 10 and mine's at number 37.
That's really gratifying.
So, yes, I have a book, Getting to Know IntelliJ IDEA, which is also on LeanPub. It's on Amazon too, but LeanPub is friendlier. So
and you have a hardcover version.
Sorry, So I did it on LeanPub because it's a nice platform, self-published, and And then when I released it, so I released the first edition. Me and Helen actually released the first edition November before last, and then I felt a bit down after it was done. I was like, why do I feel down? It's like, because I can't hold it in my hands. Then I looked into the KDP stuff, and so the Kindle Direct Publishing, so you can upload a PDF to Amazon and they'll publish you a paperback and a hardback if you want to.
Oh, nice.
Yeah. I feel down after a book because I realize the nice, clear meaning of my life just suddenly stops, But before it's like, okay, we are existing to create the book, and then it goes away.
But it is nice to have the physical thing on the shelf behind you, which we're looking at Trisha's book behind her on the shelf, and Bruce has his books behind him on the shelf.
I actually paid full price for Head First Java because I helped contribute to Head First Java, and my author copies weren't due for ages, so I paid full price so I could
just
physically hold the book.
Right. No,
feels good.
There's definitely something satisfying about that. Yeah.
So real quick on that book, it goes into, I'm guessing, IntelliJ and how to use it more effectively, and what else? What's in there?
So because I was doing advocacy for IntelliJ at JetBrains for like 7 years. So at the end of that, and I left a couple of years ago, I'm like, what? I really want to sort of download everything from my brain into something that other people can use. So the book is split into 4 sections. The first section is kind of bit fluffy in terms of like how IntelliJ thinks, like where you need to be looking inside the IDE to look for the stuff that you care about. The second 2 sections are all sort of tutorial driven. And I use TDD with it as well, because I wanted to show this is how to get the most out of IntelliJ in terms of like it will do code generation and it will make everything compile. And so there's 2 tutorial sections in the middle, and then the 4th section is actually like half the book, which is like everything else you need to know about IntelliJ. So it goes into depth about like run configurations and about like tips and tricks for debugging and how best to use the testing functionality. And I keep thinking about splitting that 4th section out and just having it as a standalone book, because it's just got so much useful stuff in there.
Nice.
Yes.
And so you wrote this book even after you left JetBrains.
We started it. I was trying to remember, because like history all blurs into one. Post-pandemic, everything is a big blur. So me and Helen started writing it in what was to become my last year at JetBrains, and then I took a sabbatical. And like you were saying about the purpose of my life in the sabbatical, I had 2 purposes. One was to help finish Head First Java, which actually came to me after I started writing the IntelliJ book. So I knew I couldn't have a full-time job and write 2 books at the same time. That just is clearly not going to happen.
Yeah.
So I had like 3 months of finish Head First Java. And in some ways, that was a crazy time. But in some ways, I sort of miss it, because I'd be like, right, get up, get the kids to school, sit down and write the book and keep writing the book. And then when that was done, then I went back and spent another like 6 months on the IntelliJ IDEA book. And I was like, we've got to get this out the door because we spent 2 years on it now. And it was supposed to be an easy thing that we can just quickly publish.
Oh, yeah.
I need a sabbatical so we can finish the effect-oriented programming book. Yeah.
Yeah, the siren song of the easy book.
Right.
Yeah, never turns out that way.
I think I might pick a hard book. I was having a conversation with Brian Getz at Devox about how do you feel about updating Java concurrency? Was it modern Java concurrency? And that's a hard book. Like I don't think that's something you can just get out the door.
Well, plus all the work that they've done on
it's a lot that's
Loom.
changed.
Oh exactly. Loom has changed everything. So I think I think you just want to write a new book,
which would be really hard.
Yeah. I'm sure. And what did he say? No way on earth.
No, I mean, he always said, I was asking him because he always said, when Loom comes out, I'll consider it. And so then he was sort of saying, I don't know if this is under like, conference dinner non-disclosure, but he was sort of saying the same thing that you just said. You can't really update the book and just like plonk Loom on the end of it. So
it's a full rethink.
He was considering having a part 2 book. So not a second edition, but
the
like
modern Java concurrency.
Exactly. Like the first book is still valid. All of that, none of that goes away. It's just that that's not the first thing you're going to think about anymore. Like how do we use fork join, and you're going to use the executors pool and Loom and things like concurrent data structures and all the stuff that's kind of come in since I think his book was Java 5, Java 6. So there's a lot to cover since then.
Yeah. Not just a refactor.
Right. No, I would say, I mean, if it was me, I would go new book. You could draw from the material in there, but just make it a new book. That's what I would do if you're listening, Brian. Just my opinion.
Well, and maybe eventually you'll have a fleet version of your IntelliJ book, and it'd be interesting to see. Can you just do a refactor, or is that a full rewrite?
Yeah, I mean, Fleet and some of the other options there, I gotta say, I'm an old-fashioned programmer. I'm like, I spent a long time learning IntelliJ. Like, I'm going to keep using IntelliJ.
Oh yeah, once you invest a lot of time in something like that.
Yeah,
once you get to know your tools, it's hard to change them.
It is hard. And Helen is still working at JetBrains, and she's more of a sort of broad knowledge person. So she's dipping in and out of the IDEs. So I was sort of hoping that maybe she might tell me what's different in the IDEs. But I'm not going to spend 15 years learning Fleet so that I can do a Fleet book as well.
Yeah. Well, and I've tried it a couple of times, and my initial reaction has always been, oh, well, this isn't as responsive as VS Code yet. So
interesting.
I'm not which I think is what they're trying to compete with, right? With Fleet.
Pretty sure. Yeah, it's basically the thought that I have when I use Fleet is, oh, this isn't for me. Not because it's bad, but it's just I'm not the sort of programmer they're targeting. And I think that some of
that's how I feel when I use VS Code. It's it's similar. So
I don't know. I use both VS Code and IntelliJ, but more, I don't know, most of the time it's like it's the little things. I find it's those little hurdles, and this is, developer productivity is one of your things, so we can work into that. But those little hurdles are what get me, and starting up IntelliJ and getting into that mindset versus just bringing up VS Code, most of the time I'll just use VS Code, and then I learn more and more about it in the process. But it's almost just the startup time that gets me. And also the simplicity. It isn't like got this huge surface area. And I've discovered this in a bunch of things. It's the little hurdles that get you. And maybe we can move into the idea of test-driven development and testing in general, because that's a big thing for you. Because I just recently, in the last few days, came across an article in my news feed where the guy was talking about, I don't remember, it was basically the things that didn't work in test-driven development. Because a lot of times TDD is something that people will go, oh, well, you have to use TDD everywhere.
Right.
And he's pointing out that, a lot of times like if you're doing exploratory programming, you don't know. If you're doing, if you're just trying to solve a specific problem, the test is the problem solved or not? And so you don't necessarily build a whole bunch of tests, and you certainly don't do the test first thing. And it's like there's this kind of narrow area where you go, oh, we have the complete specification. We can start by writing the tests for that specification that fail, and then, but that's like not that big of a,
it's not holistic of like all the different things that you're doing in the activity of programming.
Yeah, because so much of the time you don't have that full specification.
Yeah.
And if you do, sure, I can see why you'd use
Wouldn't
TDD.
The counter argument to that be that, well, you should probably go build that specification before you start writing code?
I guess, but if it's, if I'm just, well, certainly if I'm exploring, I don't know what that specification would look like. I'm just trying to figure out, is it possible to do this thing? Or do I want to do this thing? Or whatever. So what do you think about this?
I mean, everything's about gray areas, isn't it? Right. And I'm a big fan of TDD. I tend to write my tests first. Even when I used to interview people for a position where we had to have TDD as part of the job, people would say, yeah, I write my tests first, except when I don't know what I'm doing, and then I write the code first. And I'm a bit like, yeah, but if you don't know what you're doing, why are you writing the production code? Part of the thing about the tests is to write down the things that you don't know, like even if it's just the title of the tests, what should it do if the connection fails? What should it do if the user gives you some garbage input? What should it do if, I don't know, if you don't know what you're doing? So I quite often use the test to make a note of all those things that I don't know, and then kind of use that to drive the solution. But it does depend a little bit on the application you're working on and how it's architected, and like also what sorts of tests you're writing. So when I worked at LMAX, we wrote a whole bunch of automated acceptance tests. So you can be quite high level in terms of the behavior the user expects. And we wrote the unit tests too. When you're doing the unit tests, you're going to be more precise about, like, it is definitely going to do these things when you do these sorts of things. And on the acceptance test level, you can write these automated tests, which are like, well, it should definitely give me some sort of error if I do something stupid. But if you don't have those different levels of testing in a unit test, where your unit tests are like one test, one class, it's very difficult to write that general, well, I want it to do something definitely wrong when this weird stuff happens.
Yeah, so there's like a spectrum with testing where I don't often write a lot of unit tests, because a lot of the stuff that I'm building is really about integration, and it's the integration points that are brittle and can fail or be flaky. And so those are the places where I often start, is like how should the integration work? And so it's maybe a little unfortunate in some cases that I can't break that down into a unit test that has much value. But really what I care about is, like, is this integration working as I expect it to? But then that makes my tests slower because they're integration tests, and the system that I'm relying on maybe needs a bunch of setup in order to have a valid test. And so it gets
my husband writes a lot of Android stuff, and he and I both worked at the same place in London, where we worked with Dave Farley with these acceptance tests and stuff. And so he wants to test drive a lot of stuff the same way that we did there, but he does find it's a very different beast when you're working with Android, because you can't just fire up a quick unit test that does the thing that you want. But what he has found is that he often writes these integration tests or emulator level tests, because you can think that way in terms of the overall flow. But then afterwards, he will sometimes refactor those down to unit tests and be like, oh, you know what? I don't need the emulator for this. I'm actually only testing this part of the view or whatever.
Yeah.
But again, it depends.
I guess that's one way that I often do it, is I'll start with the integration test, and then I realize in trying to fulfill the integration test that, there's actually a few places that I can break down into being unit tests. And so, but I guess I'm almost in my TDD, and a lot of the stuff I build, I'm an integration test first kind of approach, and then identifying the places that could be unit tests. But
yeah, because it seems like that's not driven. I guess that's the problem that I have when people are very rigid about, oh, you always have to write the tests before you write any code. And I have discovered that when you're, at some point, well, it's almost like when you're writing a book. You write an example, and then you start writing the prose, and it changes, or at least in my experience, it often changes the example. You go,
Right.
oh, wait, you're sort of rubber ducking the example down on the thing. And so for me, testing will often do that. And you go, like, even just to make something testable, you go, oh yeah, that would change the design of it. But that isn't up front. And I think maybe my problem isn't, it's the driven part, you have to get this test first.
Yeah.
And then fill in connect the dots afterwards.
I think for me, the key thing is to be able to switch between the two, and like rapidly, because you can't just write 300 tests with no implementation and then write the implementation and expect everything to pass. Like whether you write the implementation and go, oh, now I know what the test is supposed to look like, or whether it's about going backwards and forwards. Because the other thing is that I went from this place I was working with Dave Farley, I started working at MongoDB. So I was trying to do test-driven stuff there. The pattern that they had been using is that because we were working on the Java driver, so we had a specification on how the Java driver was going to talk to the database. So a lot of the design was sort of driven from the database, like upwards, if you like, which kind of makes sense because you have a specification on how to talk to the database. And so you're sort of exposing that to the end user, and the end user is a Java developer who's trying to talk to MongoDB. But when you start thinking test first and you start thinking from the outside in, you start to realize that the API makes no sense when you're exposing what the database cares about.
Right.
And when I'm a developer, I don't really care about whatever it is the database cares about. I want an insert statement, which is going to take the thing I'm inserting and maybe some criteria. And in Java syntax, I would expect it to look like this. And so I sometimes find test-driven development, that's where I learned that test-driven development is very good for API design, because then you're starting to think from the outside, what makes sense? What shape should it be? Instead of doing what we often do as developers and go, here's what you've got. Like, just do your best with this, you know?
Yeah. Yeah. This is what makes sense based on the system that I'm abstracting over, when what the other way is to think, okay, this is what the developer actually wants from their API.
Right. And I think the biggest thing that I've come away with is when you do the testing and you go, oh, wait, this doesn't make sense. I need to change the API to make it testable. It often, or almost always, improves the API in that process. Right. So that hand-in-hand approach is just really essential, I think.
Yeah, I think as long as you're doing both at the same time and evolving in both directions. Because if you write your production code and then don't write any tests, well, A, that's bad. And B, when you come to it 6 months later and go, oh, it doesn't really work and I need some tests, and you're too scared to touch the production code to make it testable because you can't remember what it does or why it works that way, or which assumptions you made, and it's just difficult to do it afterwards.
Yeah, I think there's an important point that you brought up around how I think TDD is in some ways presented as this idea that you mentioned of like, write your tests and then switch over to your production code and then only in production code, get all of your tests to pass. Right. And I think in reality, it is this there. You've got this inner loop where you're going back and forth between your test code and your production code, and you're modifying them both at some point. And that is, I think, not generally the way that TDD is presented as the way that you should do it, but the reality to be, I think, productive is that you kind of do have to be going back and forth, adapting things.
I feel like when Luciano introduced it, that's the way he did it. He goes, okay, what do you want to do? All right, first write the test for that. Okay, now implement the code. And it was just one thing at a time. Yeah. And that did make more sense to me. But often I go, well, I'm not sure what I want to do at this point. I don't know what's possible or whatever. So, but that's just me.
There's, mostly. I think, a third piece to this that I often do is think about the data model and the functions around that data model is almost like a separate thing. Like I've got the functionality, but then I've got the data model and functions, and then I've got the tests. And a lot of times I start with my data model first, because to even write a useful test, I have to have the actual objects defined. But then when I define like a function, I in Kotlin use to do, or in Scala use triple question mark, as being like, all right, my test is going to blow up when I actually try to call this function, and that gives me the name that I can reference, but then allows me to write the test against that function that is not yet implemented. I guess in Java you could throw not implemented exception or something as well, but the triple question mark and Scala or to do and Kotlin's pretty nice for doing that. So I kind of like build out the data model and the functions, but then there's that like circular loop between all three of those different pieces to actually kind of get to where I want to go.
Right. Is this a segue that we could go into?
I want to talk about flaky tests.
Oh,
first.
flaky tests, right? Because that's a thing.
Yeah, I'm so excited about flaky tests.
Okay, tell us about flaky tests.
Yeah, I mean, everyone has flaky tests. Like if you're doing any kind of like, especially integrations, is it only like, would you only usually get a flaky test on an integration test, or does this happen?
I mean, I think you're going to find flaky tests more frequently on when you've got independent systems or messaging or integrations or like, yes, anything. I mean, you can.
And wait, can you define flaky tests first?
Good idea. Yeah.
The easiest definition of a flaky test is you run a test and it fails, and you run it straight afterwards on the same hardware, the same JVM, the same everything else, and it passes.
So it's a non-pure functional test.
It's a non-deterministic result.
Yeah.
Okay.
And so, and obviously there's different variations in that it mostly passes, but every now and again it fails versus, pass, fails. But ultimately, if you can run it under the same circumstances and sometimes it passes and sometimes it fails, it's flaky.
Yeah.
And
so
for me,
these are challenging because you then get your CI system that is flaky. Like the flakiness then propagates to cause you a lot of challenges in keeping that main branch green or whatever.
And how do you solve this problem?
There's lots yes, I'll come to that. My main problem with flaky tests is that even if you have one flaky test in your whole test suite, you stop trusting your tests. Because you're like, you already know sometimes it passes. And so you start rerunning things, whether you rerun it like locally or whether you get your CI to rerun things. This becomes inefficient, use more resources, ultimately more money. But
what does it mean to pass a test, your test suite, when one of them's flaky? What does that mean?
Yeah, and you can't trust it. You've invested all this time writing tests, whether you did TDD or whatever you did. You've written tests, you have tests, but they are not doing the job they're supposed to do because you don't have the confidence that the tests are doing what they say they're doing, and you don't have the confidence that your production code is working properly. Because if your test fails, sometimes you're like,
then your production system probably fails sometimes.
Is it the code? Is it my CI infrastructure? Like, what is it? So
and if I can't trust my tests, why write them?
Well, so here's the thing: is that I have an argument. My first argument for what to do about flaky tests is delete them. Just delete it, because I really do think that they cause more pain than any kind of security you get from that test. Because every time it passes, you're still not
kind of tricked into believing that it actually works when
right. And so I think they're toxic. I think that they lead to this lack of faith in your test suite, and not to mention the cost, the time cost, and all the rest of it. So my first answer would be delete them. But obviously you should try and fix them. And there's a bunch of different ways to fix them. So Dave Farley has a good video on this. He talks about the 5 causes of intermittent tests. And so there's things like, infrastructure changes that can happen underneath you, especially if it's a CI environment. Talks about things like versioning. So, you run it in one environment and it's fine, but in another environment, it's not fine, but you haven't versioned in your code. Like, I expect it to be using this version of the service, or I expect it to be using this version of Java or whatever. So obviously from Dave's sort of continuous delivery point of view, his whole thing is like everything should be codified. You can't just rely on it's probably there and it's probably what I expect. So that's That's another thing. And then, of course, there's a lot of things about asynchronousness and messaging and waits and timeouts and race conditions and that kind of thing. When I worked with Dave at LMAX, there was we had a bunch of flaky tests. They were mostly timeout based stuff because we were using asynchronous messaging. But it turns out that one subset of failing tests were failing for production reasons. There was actually a race condition in the production code. And the only way we found it is because we hammered it with a bunch of acceptance tests every 40 minutes, and that would bring in this race condition in a subset of the tests.
So the flaky test could be indicating to you that you've got a deeper problem, like a race condition that only surfaces given some particular state of the system.
When you're using concurrency flaky tests. So would it make sense to have a separate suite of flaky tests? So you have your tests that always should work, and then your flaky tests that you run when you're looking for deeper problems?
So one of the approaches I was talking, right, I've got so many things to say. Working at Gradle, we have a product called Develocity, which does identify your flaky tests for you. So when a test fails, it reruns it. And then if it fails and passes in the same set, then it flags it as flaky. So you get to see your flaky test. So that's a great thing. Some visibility of a flaky test is a good thing. So then I was discussing with my fellow developer advocates, like, what do we do about flaky tests? Do we just... from a developer advocacy point of view, is our message, you have to fix your flaky tests because they're noise and all the rest of it. And we realized, of course, there is a subset of tests which will by definition be flaky. Things like, flaky, not always give you the result that you expect. So, for example, one set of tests that we were running at this place were effectively smoke tests against third-party libraries and third-party systems and things. And they can fall into different categories. One is, their test system is down, so like the tests are going to fail. Another is they've changed the version. You kind of want your test to fail if they change something and your tests expect one thing and get something else back. And another is, just integration is a point of potential failure. You can't time out. Your timeout can't be infinite. Sometimes stuff goes down. So yes, anything which the test is valuable, but there is a non-zero chance that the test might fail for probably infrastructural reasons, then you want to run those probably separately, so that they're not part of your, whatever you call your acceptance testing, commit build, whatever it is. So then you can see, so you should have a set of tests, your unit tests and even end-to-end tests, which you can rely on so that the whole thing can go green, like all the time in theory. And then anything which is like, well, we just want to make sure it's probably not really stupid, can be a little bit off to one side. So that's one thing.
Is part of the underlying challenge here that we typically have a red-green approach to test passing. And there are cases where maybe it would be better to think about it in terms of a risk level or a probability level, or like, hey, we're at a 98% confidence that the system is good, and that rather than always saying you're either at 0% or 100%, is kind of the red-green approach.
Yeah, you're probably right, because if you think about performance tests, and there's usually some hard line on a performance test. So we had performance requirements of a latency of under 10 milliseconds or whatever it was. So, you want your performance test to be under that, but it's not. You can still argue it's red and green, but it is on a scale. So you want to be able to see when you're getting to 9 milliseconds, you should probably do something about that and bring it back down again.
Right.
So it's not just a case of it's fine or it's not fine. It's it's fine or it's not, it's kind of fine, or it's really going to get to be not fine quite soon. And I think we live in a world where it's not red and green, it's not black and white.
Exactly.
Everything's on a bit of a scale. It depends.
Yeah, and we don't ship perfect software to production. We know that our software is not perfect. So what level of imperfection are we okay with and still shipping? And maybe a future improvement to CI systems would be able to say, how much flakiness do you want to allow to consider this, green or able to be merged? Or
the binary.
you should also be able to flag, like, I expect this to be flaky sometimes versus I do not expect this to be flaky.
Right.
I
Yes.
don't expect when
Expected
I'm running
flakiness
two of my services under my control for them to not speak to each other or whatever it is.
Right.
I think the binary idea goes, unfortunately, filters up into management as well. You know, when we had this idea of test coverage, which hopefully is going away, you know, the managers would go, well, of course we want 100% test coverage, and then we had to go, oh, this was a bad idea. We need to change this model.
But it was measurable, so
what
if you can't measure it, you can't
manage what you can't measure.
Yeah.
That's what they say in business
That's
school.
what they say.
So right. So we gotta have measures, and if we're gonna measure it, then if I'm gonna get a promotion, then it's gotta be 100%.
That's right.
Yes.
And this comes back down to the book writing. It's like 80% complete for like 2 years. There's that last 20%, which is really hard.
The last few percent are the ones that's hard to get out of.
So different approaches to dealing with flaky tests. Maybe the uber point is that you should put some thought into how you're dealing with and how you're classifying flaky tests, and there's different approaches that you can take. You can do retries as part of that. In the gRPC Kotlin project that I maintain, we have a flaky test, and I have no idea why it's flaky. Have not been able to figure that out. And so there's a cool Gradle module, a Gradle plugin that I use that just like retries the whole test suite multiple times. And it's kind of a brute force approach, but ultimately, you know, I get a green build and that feels good. But so retries at some granularity is probably one strategy that you can take. But then I think you mentioned a few other possible approaches that you could take, and maybe something that the Gradle Velocity tooling like helps with.
So Velocity uses the retries thing from Gradle, but also from Maven to be like to flag it as flaky. So at least you're going one step further than I retried it, it went green, so it's all good. You're going, I retried it, it went green, but hey, I don't think that's right. So Velocity kind of flags that, and it shows you like these are how many flaky tests you had in this build, and you can look at it over time. So you can see your most flaky tests, which is really helpful. The other thing that came into a more recent version of Velocity is the way that I've done flaky test detection in the past, which is from build to build. Given that things haven't changed, this test tends to go red, green, red, green, red, green. So it's probably flaky. And so then you can prioritize them. And then this allows you to actually do something about your flaky tests. Because when I go to conferences and I ask people, do you have flaky tests? Some people say, I don't know. And that worries me very deeply. Because I know that when we work on very complex systems, which most of us are working on complex systems these days, our CI system is like, I'm not going to say it's red all the time. I'm going to say, you know, it's red sometimes and it's green sometimes. And, you know, I don't really know what is the real state of my tests in CI, because like you say, are they 90% passing or 1% passing? Because it went red and I'm not really sure what that means. And with at least some visibility over the flaky tests, we know, well, this goes red 20% of the time because of flaky tests. And maybe you can put them into a different part of the build, or we talk about quarantining them. I've worked in a place where you put an annotation on them which says ignore until. So you give yourself like 2 weeks to kind of like fix it. And then in 2 weeks' time, if you haven't fixed it, it starts failing again.
Oh, that's a cool approach.
That is cool. Is this part of Velocity?
No, this was when I worked with Dave Farley, and we used a JUnit annotation we created our own annotation.
So the JUnit annotation like gives you a time box that you can ignore the flakiness for, and then the tests start absolutely failing after that. It doesn't run that
test for a while, and then when the date goes past, it starts running it again, and then if it fails because you forgot to do anything about it, you're like, oh yeah, I really need to get on that thing.
It's a good point, because since I added the retry to gRPC Kotlin, I have totally forgotten that I should at some point investigate that I have a flaky test, you know, and now it's just like, oh, the build is green all the time. And so, you know, bug fixed when in reality, the bug is not fixed.
And that's one of the things we talk about from Gradle as well. And the Gradle developers do this. They schedule flaky test days so that instead of working on, you know, production code or whatever, today is a flaky test day. So we're going to use Velocity. We're going to rank our tests by something. It might be most flaky, or it might be the ones that get run the most or whatever it is by some metric, and then just go right, that's the one I'm
you have some information to guide you to what should be a higher priority than other things.
And you can see things like if it started becoming flaky in the last week, then that allows you to drill in, oh, what was that commit, what did we do, or did we change something in CI in that time? So you have more metrics to kind of dive in and try and troubleshoot the problem.
Awesome.
So what does Develocity do?
So Develocity is, I'm not sure we've got a succinct way of describing this at the moment. It is a developer productivity tool. It's on-prem, it's installed on-prem at organizations, and it allows you to do a number of different things. One, it helps speed up your build. So it provides things like build caching for Maven and Gradle. So Maven doesn't generally have there is an open source build cache, but Develocity has a better one. I have to say that. I don't know what the difference is, but there's a build cache, so it allows you to cache the output of various builds, so you don't always have to rerun builds, so you get faster builds. So Develocity provides acceleration technologies, but it also provides analytics like flaky tests, build failures, and what I think is really interesting about this is it provides it not just for CI, but for your local builds too. So in one dashboard, I get to see this test, which passes all the time on CI, is very flaky locally, and it might be a resources thing, or it might be a configuration thing, or whatever. Or I can see if one of my tests fails in my build and I go to Develocity and look at the history, I can see, oh, this fails a whole bunch for like these people on my team. And so I'm going to speak to those people about how they fixed it. So it pulls together all these stats from your builds, like local builds and CI builds, and allows you to actually start using that information to make improvements. So my experience of builds, be it Gradle or Maven or whatever, or Ant or whatever, is that someone creates the build and then we all tentatively touch it from time to time and we try not to break it, and then we just kind of live with it and accept it as it is. And Develocity says, like, because it's come out of the experience that the Gradle folks have had doing consulting for companies that run Gradle. Like, here's all the things that you can do to improve your build. This is how you can improve the performance. This is how you can improve like parallelization. You need visibility over these sorts of things. And it kind of says like, you shouldn't accept the build as a static thing. It's kind of living code the same way our code is. And if we could actually just look at it, inspect it, get some analytics, and provide some tools for things like acceleration, then it doesn't have to be this annoying thing that everyone's scared of touching that slows us down. This is something that's actually can help aid our productivity.
So in production systems, we have observability and ops, and it sounds like this tool is essentially like ops and observability for builds.
Right, exactly. And so I read something in Release It, the second edition of Release It, and he says that we should be treating our development machines and our QA environment like the production environment, because it's our environment for producing the code that goes into production. And yet actually we quite often just ignore this, or have like crappy QA environments, or like cheap laptops for developers. We don't clean stuff up after ourselves. We're just trying to get by. And so things like Develocity are kind of step in the direction. It's a step towards developer productivity and DevX and platform engineering and those kinds of things of like, let's take this area seriously. Our development environments are important. Our testing environments are important. Staging, CI, all of those things should be monitored the same way that we would with a production environment. And we should be investing time in improving those things rather than just going, well, the build takes 10 minutes and it is what it is.
Right. Well, but those things are not what the customer's paying for. The customer's paying for that code that we're working on. So those things are secondary.
But that's why Develocity is kind of interesting.
And developers are free, yeah.
Develocity is interesting because then you've got statistics. So you can say, let's say you've got a 10-minute build time for everyone on the team when they build locally. Now you have stats for how long the build takes, how frequently your developers run that build. And then all you have to do is times that by your average developer salary and figure out, oh my God, we are losing so much money just because we haven't invested a couple of days in figuring out how to reduce our build time.
But this can backfire and make developers unhappy, because then when are they going to go out and sword fight in the hallway? It's
BXKCD.
I was actually going to do a video about that. I was going to do a video about like when developers don't want to improve their productivity.
Actually, that could be very funny.
Yeah, because
I've worked environments like that.
I need these long builds so I have time to look at Twitter.
Right, exactly. I need to, I don't know, go out for a smoke or whatever it is that people do. We used to actually, so here's a story that's going to go in that video, I hope. When I used to work at a big investment bank in London, we had 3-hour release times. And we would have to kick off the release at end of day, 6 p.m. This is clearly when I didn't have children or a family or a life, actually. So we would do these releases. This is released to QA, by the way, and we would have to do this like every week for, a 3-month period while we're going through the testing phase. So we would like kick off the release process, which starts off with like database migration or whatever it is. We go downstairs to the pub. We have enough time for a drink each. We come upstairs. We kick off the next process, go downstairs for another drink, come back upstairs. And because I'm not going to sit in an empty office, it was me and my colleague, I'm not going to sit there in an empty office for 3 hours staring at a progress bar.
Right.
And so we did talk about improving that build process. And, there's a lot of pushback, the normal stuff of, oh, you can't automate this because what happens when it goes wrong? It's like, it's literally 12 pages of scripted things to do. That seems like something we should be able to automate, right? And then we could actually like kick that off and go to the pub for 3 drinks in a row and then come back.
Not have to go back and forth. Yeah.
So there's times when we don't necessarily want to improve our productivity. Similar sorts of organizations where if as developers we don't really feel valued and we do feel like we're measured by the amount of time we sit on the chair and in front of the computer, why would I want to be more effective and more productive during that time when you're literally just measuring bum time on the seat? I would quite happily manually run this script and manually copy this from here to here because I'm filling my time with something useful instead of optimizing it so I can do something else.
Why? It feels like there are fairly easy, straightforward ways to improve developer productivity. And yet it seems like generally organizations do not invest in improving productivity. Just as like a silly example, I think a lot of, especially enterprise developers, work on really crappy machines. And organizations could spend a few $1,000s per developer, get them good machines that actually like aren't super slow and always running out of memory and whatever, but they don't. And I think
because of accounting.
Yeah. But like why has it been so hard to convince organizations that developer productivity is worth it? It's worth investing in.
I don't really know I don't know the answer to that question. I do know the laptops is a good one. I worked at another investment bank in London where I went there. It's when I was working at ThoughtWorks, and I went there with my ThoughtWorks Mac, and then the bank gave me this.
They're like, here's your laptop from 1982 that you can use to build the software with.
And I was like,
don't hurt your back picking it up.
No, I'm like, this is not portable. And what do you expect me to do with this thing? It takes, and I could measure it compared to the Mac. And it was a MacBook Air. It wasn't like some super powered Mac, but the MacBook Air would run things 4 times faster at least than this brick, right?
Yeah.
And so here's an interesting thing, and this is something I've been finding with Develocity, is that one of the problems is that I don't want to blame developers, but as developers, we've been told that we don't have any power over this and we are kind of at the mercy of accounting. But once you start collecting some statistics, like with Develocity, we saw that we collected statistics of things like build times. So we've done this study where build times for one organization, I can't remember what the overall build time was, but let's say it's 20 minutes because it's not unusual. And you build it even on an M1 Mac, and then you build it on an M2 Mac, and it takes like half the time. And then they did the calculation of time versus developer salary, and like how long will this pay itself off? Like if we buy everyone an M2 Mac, like how long will it take to pay that off? Like 6 weeks or less,
right.
Some crazy, because we're measuring for all the wrong things. And if you can measure things, if you can find things to measure which impact our productivity, which is why build times is kind of an interesting one, because you can measure that.
Yeah.
And then start putting financial numbers on this, then someone else goes, oh yeah, that's a lot of money. We should probably do something about that.
So
Rather
speak
than in the
in
past,
terms,
developers have been like, my build is slow, and accounting goes, okay,
whatever. Yeah.
Right. We don't know what to do with that. Yeah. So you're saying, okay, acknowledge that the accountants are running things and just speak in their language, which is, I'd say, step one. But step two would be, maybe we should put decision making, some decisions should be made not just by the accountants.
Right.
Yeah.
And I've been speaking to some potential customers of Develocity, and some of the effective ways of making changes for developer productivity is sort of sandwich approach. So someone at like maybe C-level, or certainly some sort of like senior engineering level, decides developer productivity is important. Our developers are expensive. They're one of our most expensive resources. Let's get the most out of them. Not like squeezing lines of code out of them, but like, let's enable them to be good at their job. This is an important thing for this company. So someone at the top level says that, and the developers go, great, this is definitely something that I want. I don't want to be wasting time waiting for staff, or struggling with a terrible laptop, or waiting for CI queue times, which are like 90 minutes till my build gets in there. So if you have the top level and the developer level, you can kind of effectively squeeze in towards middle management and push in both directions to affect the kind of change. Because often you find at the mid-level, there's a lot of competing different objectives for competing different managers, and a lot of them are just obviously trying to push out features and not thinking about like developer productivity. So if you can target it from the top level and the bottom at the same time, then you can really start to affect change.
Well, I'm seeing the future as, well, we have human limitations in all of these things. You know, the accountants see it from their viewpoint, the CEOs see it from whatever they're, and I'm thinking we are going to eventually replace the C-suite with AI, and they can see that'll see everything. And it won't be these little siloed bits of knowledge that are limited by what that person has been exposed to. And companies are just going to run so much better.
But don't you think so? Yes, I would love that. But I also feel like an AI is exactly the same as a human being. Like it learns based on the weights you give to certain objectives, right? So the AI is still going to optimize for something. Well, what are they going to optimize for?
It is, but I'll say the difference is the human being can hold, whatever,
can easily ignore information.
Well, easily ignore information, and can only hold whatever 5 to 7 things in its mind at one time. So their equation is extremely limited, whereas the AI can hold all of these factors, and that's the difference.
Yeah.
It's true, and for the AI, let's say let's like. Yeah. So the AI, if you had multiple AIs at the C level, instead of them having to have a whole bunch of meetings all the time to sync, they're just kind of like sending messages to each other to update the status.
Yeah. And I don't know that you would have all these little silos
no,
anymore.
exactly.
It would just be going, oh, look, the developers are having trouble here. We need to fix that so the whole company moves better. And it isn't a matter of, well, I don't understand what long build times are.
Right.
The AI would know that, and it would go, how can we improve all of these things at once?
So one idea to run by you, we talk about developer productivity, and we had a podcast a while back around kind of the developer happiness. Like the one piece of developer productivity is like, do developers get fulfillment and enjoyment out of their flow and being able to be in flow state? But then there is the accounting side, at least pre-AI. And the accounting side, I think when we say developer productivity, accounting doesn't care. But if we said developer efficiency, like if we put it into the efficiency terminology, then there is something that maybe we could, and maybe with Develocity, we could actually have reports that illustrate like, here's ways that we could actually make developers more efficient, Yeah, I don't know. It seems like maybe by classifying everything as developer productivity, we're not actually accomplishing the goals that the developer wants, and we're not accomplishing the goals that the business wants. It's like we've kind of framed the whole thing wrong.
Yes. I liked what you said about developer happiness, because to me, the reason why I'm really excited about developer productivity is not because I want developers to ship more lines of code or even put more features in the hands of users, but because, like you said, like when I'm in the flow state, I'm happy. When I don't have to fight with my laptop, or I don't have to wait for a million years for CI to give me the answer that I want, then I'm happy and I'm creative. And so for me, developer productivity equals happiness. But then we also saw the McKinsey report, which was like developer productivity is who to fire because they're not productive, which is not what we're talking about here.
Yeah, exactly. Yeah, so there's all these different kind of lenses to look at it through, and we've kind of lumped them all under developer productivity, and maybe that's part of the challenge, is that we should break it down into more the more important things, which for us developers is, yes, I want to be in the flow state more.
That is that makes fascinating thing. I mean, that McKinsey report that you just brought up is like, oh yeah, you can take this information and you filter it through your lens, which is, oh, well, if they're not productive, get rid of them and get somebody in who, that's the solution. Whereas the other solution would be, well, and all the layoffs that we're seeing now, I look at that and I'm going, so you spent all this energy finding these people, and then as soon as a number flips in the wrong direction or somebody incentivizes you in a different way, you go, oh yeah, we'll just throw them away. You're going, that's so much.
The question wasn't how can we make them more productive? It was, well,
how do we? Yeah, well, I mean, we're a publicly held corporation. Our obligation is to maximize shareholder profits. So that's what we do. And and you're looking at it, you're going, yeah, but in the big picture, that's not maximizing shareholder profits.
It's so dumb, isn't it? You just know, like you say, all that talent goes away, all the goodwill from the developer community, kind of, you lose a lot of that, and and the productivity goes down. All the people who are left behind are demoralized, doing twice as much work, and they're scared. They're scared they're going to be let go as well. So in the not very long term, within 12 months, it's already a losing policy.
Oh, right. Well, and that's the thing, the inability of the C-level to look at the big picture. They are limited in their view. And again, I'm advocating for smarter systems, and that would be, let's let the machines do it once they get better enough. I think we will. In my opinion, the VCs are probably going to start doing this. They're going to go, well, if we can increase our hit rate, let's put the machines, managing things, because then we're going to make more money.
So Trisha, what do you do when a potential customer of Develocity comes to you and says, "Can you give me a report of my lowest performing developers?"
I had a conversation with the CEO about this week, because we're talking about how to talk about Develocity in the context of space metrics and space and DORA and those sorts of things. And the CEO was quite clear. He was like, we will not use Develocity metrics for individual performance. We fundamentally don't agree with that.
Yeah.
The aim is to empower developers so that we are in a state of flow and happy and not facing friction and toil and slow build times.
Yeah, but the answer to your question is, it doesn't matter what you do. You're already screwed when they ask you that question.
Right.
Because what they're looking for is, how do they cut costs, not how do they make their developers more efficient.
Sure. Yeah.
They're right. And we quite often talk about the idea being to increase throughput. So you're not going to cut costs. You're going to try and increase throughput. So don't fire your developers. Why don't we just get more out of them? And that will make, if you can produce more, whatever that is, more features, or, I don't even know how it works in various things. But if the code that the developers are producing is going to increase revenue, then we should be focusing on that not on decreasing headcount. Because as you've already said, like decreasing headcount doesn't make any sense, because you're going to decrease costs, sure, but you're also decreasing throughput. And then you're also decreasing your ability to improve that in the future, because now everyone hates you.
Switching gears real quick. As we were talking about observability for build systems, I wanted to ask you if you've seen this concept that I saw somebody talking about on Twitter a while back, which was the concept was, or the question was, why don't we write tests for our build system? Like we write tests for our software to verify that our production system is going to work. Why don't we write tests to validate that our build system is doing what we expect it to and doing it in the amount of time that we expect it to, and so forth? Have you seen this idea explored, or is anybody doing this? Like,
I think this is a great idea, and it's ringing bells for me, because one of the reasons we switched to Gradle a long time ago in one of the places I worked is because you could separate out the build logic into modules that you could test. I mean, we tended not to. And you could do it. We were using Ant before as well. So you could do it with Ant, because you can kind of like write little Java code and test that. I mean, it's kind of difficult, because sometimes what you want to test is it moves a file from here to here. And like, that's a sort of difficult thing to unit test, right? So I mean, I would love to test a build system and check that it's doing what I think it's doing. And I think the first thing that one of the things I like about Develocity, not to pound it too hard, because actually like I'm still fairly new to Gradle, and I'm still kind of, in many ways, I'm still trying to get them to sell to me like, what is this product and what's it for? Because like, I'm not the kind of advocate who's just going to go out and sell a product. I really have to believe in it. But one of the things I like about Develocity, and I was using it today in a video, is well, it's actually not even Develocity, it's the free build scans. So that's nice. It's free, so anyone can use it. With a build scan, you can see like visually the parallelism of your build. So you can see like it's run 5 different threads, and this is where the tasks were run. And I really like that, because it's not quite the same as an automated test, but it's at least some kind of
feedback
view into what is happening in the build. And so I use these build scans to be like, okay, I want to tune the build now. I want to, with this build, I was trying to add parallelism, add the build cache, and then I wanted to also parallelize the individual tests, which is a separate thing too. And so I can use the build scan and look at them side by side and go, obviously I can look at the overall time, but I can see, are these things running parallel? Which things came from the cache versus which compilations needed to happen again? And you can even do side by side comparison in terms of like things like, which dependencies did this build use versus this build? So, I mean, that's kind of the first step.
So you were using a tool to give you that information, and maybe some future could allow us to actually write a test to describe, yes, I want my test to run in parallel. This test should validate that my tests were run in parallel.
Right. So we have some validation scripts at Gradle. When we go onto a customer site and set them up with Develocity for the first time, there's 2 things we do. One, we set up Develocity, but the other thing we do is we start optimizing their build for them, so they start seeing the improvements of the acceleration part of Develocity, and that is scriptable. So it does things like checks out an individual commit, runs it, checks it out to a different location, runs the build, and then sees if there's any differences and that kind of thing. And then you get like pass or fail. You know, these things, the cache worked as expected because when I reran it, I got it from cache, or cache didn't work as expected because I reran it and I had to rerun everything. And so you can automate some of those kinds of things and use those things to also check for regressions. So let's say someone goes in 3 months' time and decides that they're going to, one of the things that stops the cache from working is things like generated timestamps, that kind of thing, because obviously that's like a newly generated random number or timestamp. It can't,
so somebody changes the build, they've added something that has made part of the build uncacheable, and build times go up, but you have no idea why.
Exactly. So if you've got validation scripts and you're running them regularly, it can say, this thing is no longer cached. So we've only got like 4 of these scripts. So it's a start. It's a very small start towards it. But yeah, I don't see why not. I don't see why we shouldn't be testing our build, certainly for performance, but also like Is it really doing what we think it's doing? Is it caching stuff when I expect it to?
Producing the artifacts in the way that we expect them to be produced?
Exactly. Is it like doing the right hash codes? I don't even know. Whatever it is that builds do. We should be able to check that the build is doing what we think it's doing.
Yeah, that'd be fun to explore. Cool. Well, it's fun talking about builds and productivity and all that.
Yeah, I think the thing that I'm most cognizant of from this conversation is the idea that all of that stuff, I mean, it's hard enough for somebody in management to understand what it is that we're doing in the core of it. And then the peripheral ideas of, well, how long do builds take? What are developer productivity things? That's just too much. And so that's why I think we run into these problems where we're looking at it and we're going, those are first class elements. And from somebody who you're trying to explain what it is that we do, that's just like extra too much. What do we get money from? We get money from the code that we ship. Those other things, those are just expenses. Or something. Those are peripheral. And how do we make that?
It's a mindset that needs to shift.
Well, and even as developers, for the longest time, we weren't thinking of that. Well, I'll just rerun the compiler, and there's still places out there that are just not using automated builds.
I think that's part of the problem. I think as developers, we've got really used to putting up with some crap, like long build times or flaky tests or a laptop that doesn't do what we want, or we go from environment to environment, and there's always, like, in whichever office we work in, there's something which is just, this is something we just have to put up with. And I think as developers, one of the things we can do to help our productivity is start raising those kinds of things, start looking at things which really slow us down. You know what? It does drive me crazy that the build is 6 minutes, which to me a 6-minute build time seems reasonable, but 6 minutes is not enough time to do anything else. But it's too long to sit there staring at the build. Like, and start talking about these, taking some metrics. These are the things which slow me down. Here's a metric that I get a lot with IntelliJ IDEA. If you change branches, when it re-indexes everything, it takes X amount of time, right? And these are the sorts of things where we can be like, you know what, I do this 3 times a day and it takes this amount of time. And what can we do to improve these things so that I don't have to get jolted out of my flow, and I can still be doing that lovely thing of, I'm just going to fix this problem.
That lovely thing.
Oh yeah, the whole flow thing, which is ultimately psychology, and that's even further outside of the realm of what so many people are used to thinking in terms of, but it's essential.
I tried to do a video about how IntelliJ IDEA helps us to stay in the flow. I've been trying to do this video for like 6 years, by the way. And it's so hard because I'm like, but it's just flow. Like, it just is. And you can't fake flow in a screencast because you can't explain it while you're doing it. Because half the time you're staring into space thinking anyway.
It might be one of the things that I've run into recently is trying to trying to prove why inheritance and exceptions are problems, why they don't scale, why they don't compose. And I've sort of come to the tentative conclusion that, I'm not going to be able to prove that.
Right.
And then, so I need to take a different tack, because I can't give a solid, because people are using these things and they seem to work.
Yeah.
And your video may be encountering the same problem. You're trying to solve it in a way that you can't, and you need to approach it differently.
How do you know you're in the flow state? When you're in the flow state, you feel it.
Yeah, it's like pornography.
Yeah, exactly.
I know it when I see it.
I know when I see it.
Yeah, right.
I know it when I'm in it.
Yeah.
The inheritance thing is interesting because I was poking through a code base the other day. I'm trying to parallelize the tests, actually, because the tests take the longest time, and the tests all inherit from an abstract test, which inherits from an abstract test. And I was like, no, why are you doing this? Like, and this is an experienced programmer who's done this. Like, how do I say, don't do that, apart from just saying, don't do that? But just trust me, it's just not working.
Yeah, we were talking about the most important statement in the Gang of Four design patterns book, which is prefer composition to inheritance.
Right.
And it should probably be don't do inheritance.
Ever.
But yeah, and it's like it's the same thing. You can't really, especially because we've had all this background and it worked in small talk and all this kind of stuff. It's just like, why?
The problem is if somebody asks why shouldn't I do inheritance, then it's like, oh, yeah. I can't explain the why. Just don't.
Because it doesn't scale.
It gets nasty when it gets nasty, right? I mean, the inheritance thing, when you're talking about, the duck thing that they do on Headfirst Java, inheritance is kind of fine. But in these tests, for example, there's like 200 tests, they're integration tests. It has this huge setup and teardown in one abstract method, a different setup and teardown in the other abstract method. And this is only really nasty when you're talking about hundreds of tests. Like, you're just like, but you have to see that pain.
It doesn't scale. See, that's the problem with all of these things, with exceptions, with inheritance and everything.
They seem great at first.
In the small, it looks simple, it looks direct, but then you try and scale it and you go, oh, for some reason, this isn't really working like it did in the small.
We talked about this a while back, this idea that decision making through like quorum or something works great until you get to like 5 or 7 people, and then you can no longer use that model for decision making.
Yes,
it's a lot of parallels.
I think I think we were talking about in terms of like language design and stuff. You have like 3 people and everything works really great. You go, well, just make that bigger. And it's like, nope, it doesn't work because of the psychological factors.
Right.
Yeah. And
I would argue, like trying to make decisions at home. So I have a husband and 2 children. Honestly, more than one person involved in the decision making is too difficult, especially when you're talking about like, well, he's working now but I'll be working later, and then he's got a meeting, and then the kids have got a thing, and then you don't speak for like 3 days. And it would have been easier just to make the decision there and then. And even if it's wrong, it's just better.
Yeah. Well, that's something. I took a workshop in holacracy from the guy who created this idea. And the thing that mostly I got out of it was we front load our decisions with when we make a decision, we go through all of this work to make sure it's the right decision, because if we have to revisit it, we assume we'll have to go through all that work again. And so that this approach is you make the quickest decision that you can that doesn't have any obvious, disapproval. And then if it doesn't work, then you revisit it and you again make a quick decision, rather than trying to presciently know everything about it when you make the decision, which makes it so heavyweight that you never want to revisit it.
I think you've just changed my life. Awesome. I think that would make my life a lot easier.
Yes.
As part of that, there's also the concept of like being able to perform kind of experiments that then you can validate. Did I make the right decision or something?
Yes, little experiments.
Yeah, little experiments.
Yeah, exactly. It's the same. I think it's the same sort of mindset.
Yeah. Anything else, Trisha?
No, I should probably go and check on my children. I have left them being babysat by Minecraft.
I do that as well. It's a good babysitter. Well, thank you so much for joining us. That was super fun.
Thank you for having me. This is really great.
All right. Bye.